Hello students. Hello and welcome to this video on mathematical induction. In this video, we will solve question number 81 to 90. The link to download the PDF will be in description, as well as at the end, I will show you how you can maintain an updated copy of the PDF and my question answer website, which I have created for you guys so that you can ask mathematical questions over there, because YouTube comment box is not quite suitable for mathematical content. I also make programming videos, so again, YouTube is not really good for discussion code. Therefore, I created this new web application which you can use. So without further ado, let's get started. Question 81 says that prove that 2 raised to the power 2 raised to the power n plus 1 has last digit as 7 for n greater than 1. So since the last digit is 7, then it will leave remainder 7 when divided by 10, and n is greater than 2, so we put n is equal to 2. We get 2 raised to the power 4 plus 1, that is 17, and thus it is true for n is equal to 2. We let it be true for n is equal to m. We get 2 raised to the power 2 raised to the power n plus 1 is equal to 10k plus 7. Now we put n is equal to m plus 1. We get 2 raised to the power 2 raised to the power n plus 1 plus 1, which is equal to 2 raised to the power 2 into 2 raised to the power m plus 1. Now this 2 raised to the power 2 to the power m is 10k plus 6 from this. This becomes 10k plus 6 whole square plus 1. And we see that this will leave remainder 7 when divided by 10, and hence by induction we have the result. Question 82 says that show that n cubed by 3 plus n square plus 5 by 3n plus 1 is a natural number. So we put n is equal to 1, we get 4, which is a natural number. Now we put n is equal to m, so we get n cubed by over 3 plus n square plus 5m over 3 plus 1 is equal to k, which we assume to be in the set of natural numbers. Now we put n is equal to m plus 1, and we arrive at n cube over 3 plus m square plus 5m over 3 plus 1 plus m square plus m plus 1 by 3 plus 2m plus 1 plus 5 over 3 plus 1, which is equal to k plus m square plus 3m plus 4, which is a natural number. Hence by induction we have the result. Question 83 says that show that x raised to the power n plus y raised to the power n is divisible by x plus y, where n is any odd integer. So we first put n is equal to 1, we get x plus y, which is divisible by x plus y. Similarly, next odd number 3, when you put for n, then x cubed plus y cubed is also divisible by x plus y. Now we let it be true for what n is equal to 2m minus 1 and n is equal to 2m plus 1. So we get x raised to the power 2m minus 1 plus y raised to the power 2m minus 1 is equal to f of xy times x plus y, where f of xy is a polynomial in xy. And then we compute g of 2m plus 1, so that we take as g of xy times x plus y. Now we compute p of 2m plus 3, so we have this result, and upon expansion we find that this is equal to x square plus y square times x plus y, g of x comma y minus x square y square times x plus y f of xy, which is divisible by x plus y, and hence by induction we have the result. So it is not very straightforward question that you have to assume twice for this. So therefore you need to pay attention to the solution to arrive at the result. Question 84 is similar. It says show that x to the power n minus y to the power n is divisible by x minus y. So we put n is equal to 1, we get x minus y, which is divisible by x minus y. So the statement is true for n is equal to 1. And similarly, it is true for n is equal to 2. We let it be true for n is equal to m and n minus 1. So for m minus 1, we get x to the power m minus 1 minus y to the power m minus 1 is equal to f of x y times x minus y. and we put n is equal to m, we get p of m is equal to x raised to the power m minus y raised to the power m is equal to g of xy times x minus y, where fxy and gxy both are polynomials in xy. So we have now pm plus 1, we get x raised to the power m plus 1 minus y raised to the power m plus 1 is equal to x raised to the power m minus y raised to the power m times x plus y minus xy, x to the power m minus y minus y raised to the power m minus y, which is divisible by x minus y, and by induction we have the result. Question 85 says prove that x times x to the power n minus 1 minus n a raised to the power n minus 1 plus a raised to the power n times n minus 1 is divisible by x minus a whole square for all positive integers n greater than 1. So we put n is equal to 2, we get p of 2 is equal to x times x minus 2a plus a square, which is x minus a whole square, which is divisible by x minus a whole square. So the statement is true for n is equal to 2. Now we put n is equal to m, we get p of m is equal to this much, which we let as f of xy times x minus a whole square. Now we put n is equal to m plus 1, we get x times f of xy times x minus a whole square plus m a raised to the power m minus 1 x minus a whole square, which is also divisible by x minus a whole square. And hence by induction we have the result. Question 86 says that show that n raised to the power 5 over 5 plus n raised to the power 3 over 3 plus 7n over 15 is a natural number. So put n is equal to 1, we get the sum as 1, which is 2 for n is equal to 1, we let it be 2 for n is equal to m. So we let p of m is equal to m raised to the power 5 over 5 plus m raised to the power 3 over 3 plus 7m over 15 is equal to k, where k is in the set of natural numbers. Now we put n is equal to m plus 1, we arrive at, after simplification, k plus 1 plus n raised to the power 4 plus 2m cube plus 3m square plus 2m, which is a natural number, and hence by induction we have the result. Question 87 is similar, says that n raised to the power 7 over 7 plus n raised to the power 5 over 5 plus 2n cube over 3 minus n over 105 is an integer. So similarly, we put n is equal to 1, we get 1, so the statement is true for n is equal to 1. For n is equal to m, we let the expression is equal to k, where k is in the set of natural numbers. And then we put n is equal to m plus 1. And we do simplification. Now it is quite a bit to read, okay? So I would advise you to read. And what we get is k plus 1 plus this series of factors or expression, which is divided by 7. Note that these are all 7c1, 7c2, 7c3 of that form. So they will contain a factor of 7, and this is 5c1, 5c2, 5c3. So they will contain a factor of 5, and this is 3c1, 3c2, so it will contain a factor of 3. And thus it is a natural number, and hence by induction we have the result. Question 88 says that show that 2 raised to the power n greater than n square for n greater than equal to 5. So we let it be true for n is equal to 5. We don't let it. We put n is equal to 5. We get 32 greater than 25, which is true for n is equal to 5. Now we let it be true for n is equal to m, where m greater than equal to 5. So 2m greater than n square. Now we put n is equal to n plus 1. We get 2 raised to the power n plus 1 greater than n plus 1 whole square. Now what we do is, this implies that 2 times 2 raised to the power n greater than m square plus 2m plus 1. So what we do is, we put 2 to the power m is equal to m square here. So we get 2m square minus m square plus 2m plus 1, which is equal to m square minus 2m minus 1, which is equal to m minus 1 whole square minus 2. Now we let k is equal to 5 plus a, where a greater than equal to 0. So 4 plus a whole square minus 2 is equal to a square plus 8a plus 14, which is greater than equal to 0. And thus we have 2m square greater than m plus 1 whole square. It implies that 2 of m plus 1 whole square greater than m plus 1 whole square, and hence by induction we have the result. Question 89 says that show that 1 plus 2 plus up to n is less than equal to 1 over 8 2m plus 1 whole square. So we put n is equal to 1, we get 1 less than equal to 9 by 8. So the statement is true for n is equal to 1. We let it be true for n is equal to m. That is 1 plus 2 plus so on up to n is equal to 1 less than equal to 1 by 8 to m plus 1 whole square. Now we put n is equal to n plus 1. So left hand side is sum up to n plus 1 and right hand side is 1 by 8 times 2m plus 1 whole square plus m plus 1. So we don't put n equal to m, we just add n plus 1 to both sides. Now this is equal to 1 by 8 times 2m plus 3 whole square, which is 2, and thus by induction we have the result. Question 90 is a famous inequality. We have to show that n raised to the power n less than equal to n factorial whole square, where n greater than equal to 2. So first we put n is equal to 3, n is greater than 2. Yep. So we put n is equal to 3, we get 3 raised to the power 3 less than equal to 3 factorial square, that is 27 less than 16. So it is true for n is equal to 3, we let it be true for n is equal to m, where m is in the set of natural numbers and m greater than 2. So we have n raised to the power m less than m factorial whole square. Now we have to prove it for n is equal to n plus 1, so we get n plus 1 raised to the power m plus 1 less than m plus 1 factorial whole square. Now we divide Pn plus 1 by Pn. We get n plus 1 raised to the power m plus 1 over n raised to the power m less than m plus 1 factorial over m factorial whole square, which is equal to m by m plus 1 whole square times n plus 1 over m raised to the power m plus 1, which is less than 1. Thus we have n plus 1 raised to the power m plus 1 less than n plus 1 factorial whole square. And thus by induction we have the result. And with this we come to the end of 90 problems on mathematical induction. Now I'll show you the website. So my website is ashtawork.org. You can download algebra, trigonometry, and coordinate geometry books from here. As you can see, algebra was uploaded yesterday. Now when you download, the file names won't have dates in them. So you should add the date of this modification date. And after 15-30 days, you should come back again and check if a new copy has been released. And then you can download again and date the date. I can't put date in the files because links on YouTube will become invalid every time I upload a new PDF. So I keep updating them as I find the errors and all. So once algebra is finished, trigonometry will start receiving update. And algebra will keep receiving updates for a long time. There are lots of typing mistakes. It will take a while to actually fix all those. And I don't have anybody else. Plus, other than recording YouTube videos, I write the books and develop the question answer website. So I get very little time. Now, if you want to ask questions, you can click on the H link. You can come to kundika.ashtawork.org and create a login and ask questions here. It supports MathJax, so you can use LaTeX formulas in the math to ask questions. And I have tags for you: algebra, calculus, coordinate geometry, geometry, probability, and trigonometry. So you can make use of these tags. If you need more tags, ask me and I'll create them. So creating login is very straightforward. You click register, click the username and an email, and they will be sent a confirmation link. You click that link and your email will be verified. For login, you send that, you give an email, and you will receive a code on mail. You put that, you will be logged in, and then you can ask questions and answer questions as well. So I hope that you are enjoying this series of videos on algebra, and I hope that you are finding it useful. So thanks a lot for watching the video. We will meet again tomorrow with 10 more problems on mathematical induction. I will take my leave now, and you have a great day and keep learning and enjoy.